with inverse functions, I am going to skip these first two pages. These are a super good activity for actually learning the inner workings behind inverse functions. And this is something I do want to go over, yet I think that this is best suited for class. So what I'm going to plan on doing is printing off this first sheet of notes for everyone. And that's what we can do to start class for this section here. But I do want to go through some of the worked out problems for this section here, just to give you guys a little idea on how to actually go about solving these. Once again in class, we can go through that first page together. So for determining the inverse equation for a function, basically all we're going to do is switch x and y. So remember, f of x is notation for output, just like y. So if you have f of x, you can swap that for y as well. So once we switch x and y, we're going to solve for y to undo the operations. And then we're just going to use a -1 as our notation for an inverse. We can go over that once we get to it. So first example here, we are given a bunch of ordered pairs. This is the easiest way to solve for an inverse. So this f to the negative first power, that's the -1 to denote inverse. And all we're going to do is rewrite our set, swapping our x and y values. So we have 1 and 3. We're going to swap that to be 3 and 1. And then we're just going to keep going. -1 and 1. -3 and 1. And then 1 and 1, the inverse is just 1 and 1. And there we go. That's how we determine the inverse for that function. And yes, in this case, it is a function. If we were to get an irrational or imaginary solution, that's where we would not have a function. Okay, so let's go on to number 2 here. We'll just stick with the left side. So first of all, we have g of x equals 2x minus 1 over 3. Remember, g of x is pretty much just y. It's just the output. So step number 1 here, we're going to swap our x and our quote-unquote y value, g of x. So I've got x equals 2y minus 1 all over 3. And now all we're going to do is solve for y. So I'm going to start by multiplying by 3. So this gives me 3x equals 2y minus 1. I'm going to add my 1 to the other side. So I've got 3x plus 1 2y. And then I'm going to divide by 2. So I've got 3x plus 1 over 2 y. So I solve for y. So now to write my inverse, I'm going to write this as the inverse of g of x equals 3x plus 1 all over 2. And in this case, this would be a function. It would pass the vertical line test. So in number 4 here, let's do the same process. Let's swap our x and y. So I've got x equals y plus 2 squared minus 3. Okay, let's go ahead and solve. Let's add 3. So I've got x plus 3 equals 2 squared. I'm going to take the square root of both sides. So that's going to give me, remember, plus or minus the square root. X plus 3 equals y plus 2. And now I'm just going to subtract 2. I've got -2 plus or minus the square root of x plus 3 equals y. And now I'm going to write this as an inverse. So I've got g of negative 1. So the inverse of g equals negative 2 plus or minus the square root of x plus 3. Okay, if you were to graph this, this would end up giving you some sort of sideways looking parabola. I can actually sketch it for you real quick. It would give you something that looks like this. And this would not be a function because it would fail the vertical line test. Okay, so another way that you can tell whether or not functions are inverses of each other is by using composition. So with composition, if you were to compose the two functions and you were to get x as your result for both compositions, so in this case, if I was to take f of g of x and get x, and if I was to take g of f of x and I would get x, then yes, they would be inverses. But in the case that your composition of either way is not g of or is not x, then you do not have inverses. So let's give number 6 a try. So if I have f of g of x, and you do need to try this both ways unless you come upon a non-inverse. Let's do this. So first of all, I know that g of x equals negative 2x plus 3. So now I'm going to substitute negative 2x plus 3 in for x. So f of negative 2x plus 3 is going to give me 2 times negative 2x plus 3 minus 3. I'm going to distribute my 2. So I've got negative 4x plus 6 minus 3, which is just going to give me negative 4x plus 3, which this obviously is not x. So I can automatically conclude that these are not inverses. Okay, when we do the opening activity in class together, you'll see why this is the case, but no reason to explain now in the notes video. So you can determine whether you have inverses by composition. You can also determine whether you have inverses by graphing. So what they want us to do is they want us to graph the inverse. So what I'm going to do is I'm going to find a couple good points within my graph that cross nicely. So for each of these points, I just picked 3 of them. You can pick more if you'd like. I'm just going to switch my x and y value. So if I'm to write my ordered pairs, I would have negative 1, 1. Right here, I would have 0 and 3. And up here, I would have 2 and 7. So to draw my inverse, all I'm going to do is switch my coordinates. So if I have negative 1, 1, now I'm going to have 1 and negative 1. And if I was to have 0 and 3, now I'm going to have 3 and 0. And 2 and 7 turns into 7 and 2. And now I'm just going to graph my line. Try to use a purple. Okay. So that is my inverse right there. Now, determine whether the inverse is a function. Well, in this case, my inverse, my purple line here, does pass the vertical line test. So, yes, this would be a function. All right. So that is just a quick rundown on inverses. We are going to spend quite a bit of time in class going over these. So don't worry if any of the last 3 sections were still a bit confusing. All right. Thanks for watching.